Hi students, it's Mrs. Kusalaba and I'm filling in for Miss Sadakran today because she is still out on a sick day. So we're covering lesson 211, which is all about chemical equations. I do have a study guide for you in the lesson module 211 that you can download and have at your desk. So if you want to pause me at any time, feel free to go and grab that and have it open, because on your study guide, I'm going to go ahead and go through all of the quiz questions and answers for today. All right, first let's talk about what a chemical formula is. A chemical formula is an expression of the types and number of atoms in a substance. So let's look at water, for example. It tells us what type of atoms there are, and you can see the different letters. H and O represent the atoms. So H stands for hydrogen, O stands for oxygen. Hopefully you've already learned that when you learned about elements. The number that you see here represents the number of atoms. So there are 2 hydrogen atoms in every water molecule. And you'll see that there's no number by the letter O for oxygen. The no number is supposed to represent only 1. That's just something you'll have to memorize. So every compound in the world has a formula like this. It's chemical formula. It's kind of like a recipe. It always tells us the types of atoms that are in the compound and how many atoms of each type are located there. So let's take a look at how to read the chemical formula for table salt, which is NaCl. How many different atoms are in this compound? Hopefully you've noticed that Na is an element, Cl is an element, so there are 2 different atoms in this particular compound of table salt. How do we know how many atoms, how many sodium and how many chlorine atoms are in each one of these? Well, there's no number, so that represents just 1 atom of sodium and 1 atom of chlorine. Again, we need to look to see if there's any little numbers. If there are little numbers, that indicates how many of that element or atom are in this compound. Okay, so there are 3 carbon atoms in every propane compound or molecule. There are 8 hydrogen atoms in every molecule of propane. And this is always going to be its chemical formula. Think of it like a little recipe, if you will, for the substance that we're looking at. So C3H8 is always going to be propane. Okay, if I asked you on a quiz, what's the chemical formula of this compound right here? What would you answer? Hopefully you responded NaCl. The Na stands for a sodium atom that's chemically bonded, that's what that stick is right there, to chlorine atom. Okay, so the chemical formula for this molecule, this compound, is NaCl. Now if I asked you, what are the types of atoms in NaCl? Pause the video and think about or write down your response. Good. Hopefully you said there are 2 different types of atoms. One of the atoms in this compound is sodium and the other is chlorine. How many of each type are located in NaCl? Pause the video, think about it, and come back. Good. Hopefully you said there is 1 atom of sodium, there is 1 atom of chlorine in every NaCl molecule. All right, what is the chemical formula for this compound? It's bicarbonate, and the answer is actually up here on this image. Hopefully you said HCO3. HCO3 is the chemical formula, it tells us exactly what's in every molecule or every compound of bicarbonate. So for practice, how many types of atoms are in bicarbonate? Well, let's count. So there's 1, because that's a hydrogen. That's 2, because there's carbon. And 3, because there's an oxygen. So there are 3 different types of atoms in bicarbonate. But how many of each type? How many hydrogens do you see? How many carbons and how many oxygens do you see? We could go over here and look at the letters and count them up, or we could remember that if we see no number right here, no little subscript number, that means 1. So there is 1 hydrogen, 1 carbon, and 3 oxygens in every bicarbonate atom, or I'm sorry, molecule. Some students remember a way of looking at molecules like as if you were building with Legos. So if you think of each element as a different color Lego, you could think about putting those Legos together to create different molecules and different compounds. So you can see right here they represented the black Lego as a carbon and 2 of the red Legos as oxygen to represent a molecule of CO2. Sometimes in chemical formulas, you're going to see a big number in front of the chemical formula. That big number stands for how many molecules there are of that substance. So for example, we all know that this is a molecule of water, H2O. The big 6 in front of H2O stands for 6 water molecules. So you want to remember that big number is how many molecules there are. Well, now that we know that there's 6 molecules of H2O or water, how many hydrogens are there? Pause the video and think about it for a second and come back. Well, some of you might have rewound and saw that each little white block was a hydrogen, and maybe you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But without counting, all we have to do is take the little subscript number and multiply it by the big number to get your total number of hydrogen atoms. So there are 12 hydrogen atoms because 6 times 2 is 12. How many oxygen atoms are there in this total of 6 molecules? Hopefully you said there are 6 because 6 times 1 is 6. Okay, so the big number is how many molecules of the substance there are. So there are 6 carbon dioxide molecules here. But how many of them are carbon? How many atoms of carbon are there total? Pause the video and come back. Hopefully you said 6 because there's an implied 1, and that 1 times 6 is 6 carbons. Now to find out how many oxygens, we could take the 2 and multiply it by the 6, and we could find out that there is 12 oxygens. You could even count them down here if you want to check that answer. All right, so we know what a chemical formula is now. Chemical formulas are those letters that are put together to tell us how many atoms and what type of atoms are in a specific chemical. Let's take a quick look at what is a chemical reaction.
What is a chemical reaction? To start with, all matter, whether it be water, salt, rust, carbon dioxide, or oxygen, is made up of atoms held together in unique ways, and we call these chemicals. In a chemical reaction, these atoms are rearranged to form new and different chemicals. Let's look at an example. In this chemical reaction, we have magnesium atoms being rearranged with a molecule of carbon dioxide, and those atoms now make a chemical called magnesium oxide plus carbon. Let's look at another example. In this chemical reaction, we have hydrogen gas and oxygen gas, and they're being rearranged to form molecules of water. So to sum up, a chemical reaction is a process that transforms one set of chemicals.
Okay, so chemical reactions are what is formed when we combined two different chemicals and we create a new substance with totally different properties. Let's take a look at study guide answer number 1. All right, so we can combine molecules into a chemical reaction to create what we call a brand new substance. And we use what is called a chemical equation to show the reaction that happens. Okay, let's take a look more at study guide answer. I believe this is still number 2, guys. Let's go to number 2 now. Okay, so we need to talk about what the law of conservation of mass is. Take a look at our starting coal here. We will burn up the coal, and then we are left with this much coal here. What do you observe? Pause the video and jot down your observations. It kind of looks like there is less coal on this side over here after we burn it, after we light it up and burn it on fire. But there's actually 100 milligrams of coal when we start, and there's 100 milligrams when we finish. So did the coal really disappear? Did it go away? The answer to that question is no. Mass, meaning matter, is neither created nor destroyed by chemical reactions. So whatever chemicals you start with, you always end up with, even if the properties are different and it's a new substance and it acts different or behaves or even looks different. So remember, matter cannot magically disappear or appear. It has to come from somewhere. So the mass, or the amount of matter that you have before a chemical reaction happens and after the chemical reaction happens, is actually going to be the same. The reason it's the same is because all of the atoms that we started with in the reactant side here is going to be the same amount of atoms in the product side. No new atoms are created. No new atoms are destroyed. However, we might have a brand new substance where the atoms just rearranged with each other. Okay, so the answer to study guide number 2 and 3 here is on the left side here, you're going to see the reactants. Think of the ingredients that you would use to make or bake a cake or cookies. The ingredients that you add to make the cookies are called the reactants if you're talking about a chemical reaction. The outcome, or say the cookies or the cake that you get, is the product, because it's a new substance that's entirely different acting, different smelling, maybe different tasting, different looking than the originals that went in. And that is called a product. So on this left side here, we've got the ingredients called the reactants, and the outcome after we do a chemical reaction is called the product. Okay, let's go to study guide answer number 4. Here's an example of atoms going into a chemical reaction together to create a new substance. This is a real-life process called photosynthesis and cellular respiration. Guys, don't have to remember this chemical formula at all. This little diagram is just showing you that you're starting out with 6 water molecules and 6 carbon dioxide molecules. And after we add some light and some photosynthesis happens, we actually end up with glucose and oxygen. However, I drew you these little lines here to show you that you see how we started with hydrogens over here? We're going to end up with hydrogens and the same amount of them over there. Same thing with oxygen, same thing with carbon, and same thing with these oxygens as well. So we have different substance being formed. However, none of the matter, none of the atoms were destroyed in the process, because on Earth, we can't create or destroy matter. Whatever we start out with, whatever atoms we have at the beginning in our reactants are the same amount of atoms that we have in our product. They're just rearranged differently to create a new substance. All right, let's take a quick look at rearranging atoms in a chemical reaction. You're going to keep your eyes on the reactants, or the methane and the oxygen atoms. Let's take a look. In this example, we're just doing combustion of methane. I'm going to click the play button, and I want you to watch the actual atoms. So this black, silver, and red, these are all different atoms. This is a molecule of methane. This is molecules of oxygen. Watch what happens to the individual atoms as I click play. See, they're breaking apart. And now they're going to go through a chemical reaction and they're going to form carbon dioxide and water. Let's watch. Okay, so it looks like that the 4 hydrogens split off of the carbon over here, and then they bonded with a couple of the oxygens. Let's keep watching. All right, since there was some product left over, it looks like we have carbon bonded with the last 2 oxygens that were left over to create carbon dioxide and water. So that's an example, guys, of a chemical reaction happening, and that is the chemical equation. All right, let's go through the last 2 answers on the study guide. Question number 5 is asking, what is wrong with this equation? Okay, how many hydrogen are on the reactant side? How many oxygen are over here on the reactant side? And how many do you see over here in our product side, or our H2O water molecule? Do you see the discrepancy? Do you see what's wrong with this picture? Hopefully you paused the video and came up with the answer. There seemed to be a different number of each element on each side. So let's go back and take a look at that. There are 2 hydrogens on this side, and there are 2 over here on the product side. However, what do you notice? There's 2 going into the chemical reaction over here on the reactant side of oxygen, but how many are over here on the product side? There's only 1. Okay, this cannot happen. The reason this cannot happen is because matter cannot be created or destroyed. Whatever amount of atoms you have on the reactant side has to be the same amount over here on the product side. Okay, and your last study guide question. Okay, there is a missing element here. We're just calling it X. So what would you do to find out which molecule or which atoms are missing right here where the X is located? What should be over here? What do we do? Pause the video for a second, see if you can figure it out. Okay, hopefully you notice that there's potassium here, there's P's over here, and there's a P over here. Hopefully you notice there's oxygen right here, and there's oxygen over here. But which one is missing over here on the reactant side? Well, the product side has 3 H's. So what would we put over here? We'd have to make sure that there were 3 hydrogens, right? 3 H's over here on the reactant side. Because matter can't be created or destroyed, we have to have the exact same number of atoms on both sides of the equation. If you need to pause the video at this time, here's a summary of all of the answers for that study guide. This should help you with the quiz today. The quiz is going to cover all of these different questions. And if you get that done, what you'll want to do is go back in and read the lesson, check your notes in your study guide, fix anything wrong that you thought maybe you forgot to include when you wrote down everything you're remembering. The daily quiz will open by 2 p.m. today. And we don't have a science party because Ms. Sudhakaran is out. So hopefully she'll see you on Wednesday, guys. Thanks for letting me talk to you for 20 minutes. If you have any questions, make sure you send Ms. Sudhakaran an email. She'll get back to you just as soon as she can. Thanks, guys. Have a great day.